Welcome back. Good evening to you. I remain Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall continue our study on GCD and LCM, greatest common divisor and the least common multiple of two or more numbers using the prime factorization method. This is part 2, so please, before you view this video, please view part 1. Very important. Importante. Es importante. So please, before you view part 2, view part 1 first, before continuing with this. Okay? So from where we stopped in part 1, we are going to begin here from question 3. We did questions 1 and 2 in part 1. So here we're going to do we will start from question 3. Question 3 says, find the GCD of 1001 and 1331. So we will begin 1001. We look at the prime factors that are prime numbers. 2, this is not an even number, so 2 is out. 3, 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1, 2. So the sum of the digits is not a multiple of 3. So 3 will not divide that. The next one, 5, because we are looking at prime numbers. 5, this number does not end in 0 or 5. So because it does not end in 0 or 5, 5 will not divide that without a remainder. 5 is not a factor of 1001. The next one is 7. 7. With 7, let's look at divisibility by 7. Divisibility by 7. Let's bring it closer here. Divisibility by 7. So with 7, what you do is you get the last digit, multiply it by 2, and subtract it from the remaining number. So you keep on doing it. Until you get, you get a number, at least 2-digit number, and then you can find out if that 2-digit number is a multiple of 7. That means 7 can divide that. If the 2-digit number is not a multiple of 7, that means 7 cannot divide that. So, like I said, this is 1001. So you get the last digit. The last digit is 1. Multiply by 2. That gives you 2. Then subtract it from 100. Okay? So you get the last digit, remove it. So get the last digit, remove last digit. Remove last digit. That is 1, which is 1, equal to 1. Then multiply by 2. Multiply by 2. So this will be 1 times 2, and that is 2. Then you subtract it from the remaining number. Subtract from remaining number. Subtract from remaining number. So remaining number is 100. So 100 minus 2 is 98. You ask yourself, is 98 a multiple of 7? We know that 7 times 12 is 84. Okay, 7 times 12 is 84. 84 plus 7 is 91. So 13 times 7 is 91. 91 plus 7 is 98. So 14 times 7 is 98. Okay, so this is what I'm saying. 14 times 7. Okay, 14 times 7, 7 times 4 is 28, 2. 7 times 1, 7 plus 2, 9. 98. So 7 is a factor of this. So because when we subtracted it and we had a difference, the answer you get from subtraction is difference. So 98 is a multiple of 7, and because of that, 7 can divide 1001. So we write 7 times, and let's, because of time, let's use calculator. So we do 1001 divided by 7. That gives us 143. So we have 143. Okay. Then 143, 2, well, because 2 and 3 didn't go anywhere, so 2 and 3 didn't go in the first place. 2, 3, 5 didn't go in the first place, so we remove it. Now let's try 7 again. Remove 3. 3 times 2 is 6. 14 minus 6 is 8. Okay, remove 3. 3 times 2 is 6. Then do 14 minus 6 is 8. So 7 cannot divide 8 without a remainder. So 7 cannot divide 143. So that's out. 7 again is out. Then we try 11. Divisibility by 11. Divisibility by 11. We look at 2 methods. Okay, I'm going to explain 2 methods where you can do this and see. First method, second method. If you have the first method, you have 1001. By 11, remove the last digit and subtract that last digit from the remaining number. So remove 1, remove the last digit, that is 1. Remove last digit. Okay? So remove 1. Then subtract it from, don't multiply it by anything. Just remove the last digit, then subtract it from this remaining number. 100 minus 1 is 99. So 99, you can divide 99 by 11 without a remainder. So 11 will go. So 11 will divide 143. 11 will divide 143. So we're going to write 11. Now, let's look at the second method. We'll be talking about 143, not 1001. Please, I'm sorry. Let's talk about 143, not 1001. So 143, now 11 can divide 1001, but we are looking at 143 because that is the thing remaining. Okay, 1001 divided by 7 is 143. So let's see this 11. So you do 3, remove the last digit, 3. Then do 14 minus 3 is 11. So 14 minus 3 is 11. So 11 can divide 11. So 11 can divide 143 without a remainder. So we write 11. That is the first method. Now the second method that we do is you can find the difference between the sums of the alternating digits. Okay, difference between the sum of the alternating digits. Alternating. I'm going to use the yellow chalk. Alternating means first and third. This is alternating. So add the alternating digits. Okay, first, third, fifth, seventh. Then add second, fourth, sixth, eighth. So depending on how long the number is, add the alternating digits, and then subtract, find the difference between the sums of those alternating digits. It doesn't matter whether it gives you negative number, it doesn't matter. Provided it is divisible, you keep on, you do it. If it's divisible by 11, that means 11 can divide that number. So we add the alternating digits. 1 plus 3 is 4. Now we don't have any fourth number, so it doesn't matter. So we still get this 4. Okay, we do 4 minus 4 is 0. 0 divided by 11, it gives you 0. So 0 divided by 11 gives you 0. So 11 can divide 143. Okay, that's the two ways you can do it. And I really want to give credit to 2 websites that I reviewed to know the divisibility by prime numbers. One is Savori.de. That's from a German. .de is from Germany. So Savori.de. So he has, I don't know whether it's he or she, I don't know, I'm sorry. I say guten Nacht, guten Nacht, right? That is good evening in German. So I'm greeting the person, guten Nacht, guten Nacht, guten Nacht. Okay, please, I'm sorry, Germans, I'm sorry. So if I am not pronouncing it right, I don't know, Deutsch, guten Nacht. So that is, I got this first method from that guy, okay, for divisibility, this first method. And then I got the second method here, difference between the sums of the alternating digits, from mathwarehouse.com. So this one is from Savori.de. .de is Germany. And then this one is mathwarehouse.com. So I got that from them. So I'm giving them the credit, right? Now, so 11 divide 143. We now do 143 divided by 11. That gives us 13. So we write 13. Okay? So this is 77 times 13 is that 1001. Then we do 1, 3, 3, 1. 2, this is not even number, so 2 is gone. Then 3, 1 plus 3, 4 plus 3, 7 plus 1, 8. It is not, the sum is not a multiple of 3. That's out. 5. This does not end in 0 or 5. So that's gone. 7. Remove 1, multiply by 2. 1 times 2 is 2. 133 minus 2 is 131. Right? 133 minus 2 is 131. So 1 times 2 is 2. Then 133 minus 2 is 131. We still don't know about 131. So remove 1 again. 1 times 2 is 2. Now 13 minus 2 is 11. 13 minus 2 is 11. 11, 7 cannot divide 11 without a remainder. So 7 is out. 7 is out. Now let's try, then after 7, the next prime number is 11. So let's try that. So we have 1, 3, 3, 1. So do 133 minus 1, remove 1, the last digit. Then do 133 minus 1 is 132. 11 times 12 is 132. So 11 can divide this. 11 can. So we write 11 times. And if you want to use the second method, 1, 3, 3, 1, So we have the first and third. This is first, this is second, this is third, this is fourth. So add the alternating digits. Add the alternating digits. 1 plus 3 is 4. That's the first and third. First and third. First plus third. And then 3 plus 1 is 4. This is second and fourth. Second plus fourth. Then you now find the difference between the sums. So 4 minus 4 is 0. 0 can be divided by 11. So yes, 11 will divide that. Then we now do 1331 divided by 11. That gives us 121. And 121 is 11 squared. So this is 11 cubed. 11 cubed. Okay? 11 cubed. 1331. Okay? So now, this is 7 raised to power 1. This is 13 exponent 1. So this is 11 cubed times 7 exponent 0 times 13 exponent 0. So we want the same prime numbers on both of them. The same prime numbers on both of them. That's why I put 7 and I put 13. Now, law of exponent, anything exponent 0 is 1. So please, we discussed this in part 1. So please look part 1, view the part 1. So now we now say that the GCD of 1001 and 1331 is equal to 7 exponent minimum of 1 and 0 times 11 exponent minimum of, this is 11 exponent 1, minimum of 1 and 0 times 13 exponent minimum of 1 and 0. I'm sorry, 11 is 1 and 3. 11 is 1 and 3, okay? 11 exponent minimum of 1 and 3. Okay? So this will be 7, minimum of 1 and 0 is 0. 7 exponent 0 times 11, minimum of 1 and 3 is 1. Times 13, minimum of 1 and 0 is 0. So this will be, this is going to give us 1. Anything exponent 0 is 1. 1 times 11, 11 exponent 1 is 11. Times 13 exponent 0 is 1. And that gives us 11. So that's our GCD. Okay? And then the LCM, because we are doing both of them, LCM of 1001 and 1331. And please, like we say, if you go to that website, www.modular-arithmetic.oxford.com, you can check your answers, of everything we've done. You can check your answers with that. So the LCM will be 7 exponent maximum of 1 and 0 times 11 exponent maximum of 1 and 3 times 13 exponent maximum of 1 and 0. So that gives us 7 exponent 1, because maximum of 1 and 0 is 1. Times 11 exponent 3. Maximum of 1 and 3 is 3. Times 13 exponent 1. So that gives us 7 times 1331 times 13 times 13. And what do we have, folks? We now have 7 times 1. 7 times 1331 times 13. And that gives us 121, 121. As as answer. Ok? Comprendez? Comprenez-vous? Una otaraya? I bet you didn't understand the third language I spoke, right? Una otaraya? Una otaraya? Okay. Okay. So, and you can check. Remember we talked about checking in the part 1 of the video. We talked about check that we said that the check is that the GCD of MN times LCM of M and N is equal to N times N. So you have left hand side, right hand side, GCD of 1001 and 1331 is 11. 11 times 1, LCM is 121, 121. And the right hand side is 1001 times 1331. Right? So if you multiply that, it will give you this. It will give you that. 11 times 121, 121. So this gives us 1332331. And then you do the right hand side, 1001 times 1331. Gives you 1332331. And then you can jump up and touch the ceiling. Okay, thank God this works. Okay, now let's go to question 4. Quattro. Let's go to quattro. Question number 4. Quattro. Ano. Question 4. Okay, we have find the GCD of GCD and LCM of 1, 2, 3, 4, 5, and then 5, 4, 3, 2, 1. And these were the questions we did using Euclidean algorithm. You know, this is a video playlist. It is a video playlist. If you go down that playlist, we still solved these problems using Euclidean algorithm. All right. So we start with 1, 2, 3, 4, 5. This is not an even number. 2 is out. 1 plus 2, 3. Plus 3, 6. Plus 4, 10. Plus 5, 15. So 3 can divide this. We write 3. We write 3. Then we do, to save time, 1, 2, 3, 4, 5 divided by 3. That gives us 4115. So we have 4115. Let's try 3 again. Okay, we keep on trying. 4 plus 1, 5. Plus 1, 6. Plus 5, 11. So 3 is out. 3 cannot divide it anymore. Now, the next one, 5. 5 can go. Okay, so we write 5 here. We write 5. So 4115 divided by 5. That gives us 823. 823. Okay? 5, this is not, it does not end in 0 or 5. So 5 is no more. We're not going to use 5 anymore. Now 823, the next one is 7. Let's try 7. 823. Try 7. So 823, bring out 3. 3 times 2 is 6. Then 82 minus 6 is 12 minus 6 is 6. 7 is 6. 7 cannot divide 76. No. Okay? So 7 is out. 7 is out of the game. We try 11. 11. So 826, 823. We do 82 minus 3. 82 minus 3, 12 minus 3 is 9. 79. 11 cannot either. Okay? And even if you do this second method, 8 plus 3, 11. 11 minus 2, or 2 minus 11 is minus 9. 11 cannot go. Okay? So that is the second method, is what I just used. So the next one is divisibility by 13. Divisibility by 13. So let's look at divisibility by 13. Still from that site, savori.de. With 13, get the last digit, multiply by 4 and add. Okay? Get the last digit, multiply it by 4 and add. If it gives you a number and you keep doing it, if it gives you a number that is divisible by 13, then 13 can divide that. So we look at 823, 3 times 4. Get the last digit, 3. Remove it. Multiply by 4. That gives you 12. Then do 82 plus 12. That gives us what? 94. 94. Okay? 13 cannot go into 94 because 13 times 5 is 65 plus 13. Now 13 times 6 is 78 plus 13 is 91. 13 times 7 is 91. So 13 cannot go. 13 cannot go. If we do it also here, 823 divided by 13 gives us a decimal. 13 will not go. We do divisibility by, after 13, the next prime number is 17. So divisibility by 17. With 17, remove the last digit, multiply by 5, and then subtract. Okay? So we have 823. So remove the last digit, 3. 3 times 5 is 15. And then subtract from the remaining number. 82 minus 15. 12 minus 5 is 7. 7 minus 1 is 6. 17 cannot go. Okay? 17 cannot go because 17 cannot divide 67. 17 times 4 is 58. 68. 17 times 4 is 68. Okay? 4, 7, 8, 2, 4, 1, 4 plus 2, 6. So 17 cannot go. And if you do it also, 823 divided by 17, it gives you decimal. Now let's try 19. 19, the next one is divisibility by 19. Divisibility by 19. With 19, get the last digit, multiply by 2, remove the last digit, multiply by 2, add it to the remaining number. Okay? So we have 823, remove the last digit, 3 times 2 is 6. Add it to the remaining number. 82 plus 6 is 88. Nineteen cannot divide 88. So because of that, it will not work. If you do 823 divided by 19, it gives you decimal. So now, you can't keep on, we can, so you've tried all this. What you can now do is this, okay? You take the square root of 823, because if you're working with time, you can't keep on testing after 1923. After 23, 20, 29, 31. I mean, you can't keep, if you're working with time. So what you can do is this, find the square root of 823. Find square root of 823. Okay? Find square root of 823. And that gives us 28.687, 688 approximately. 28.688. And we've got, so what this means is this, okay? If we find a number, if we're gonna find a number, we keep doing it up to 28. If we're gonna find a prime number that can divide 823, okay, at least one of that number must be less than 28. Do you understand what I'm saying? So if we're gonna find any prime number that will divide 823, at least one of that number must be less than 28. So let's keep doing this up to 28. Let's keep doing it up to 28. Okay, so we've done 19. Excuse me. It didn't work. The next one is, after 19 is 23. 823 divided by 23. 23 didn't work. Use us decimal. After 23, 4, 5, 6, 7, 8, 9. It's 29. No need. Okay? No need. No need, because if there's any one, it has to be less than, has to be at least, it has to be at most 28. So we didn't find. So we just write 823. Just write 823. Because 823 is a prime number. We can't find anyone, so it's gonna be 823. And if you keep doing it, you won't find. You will not. If you do 823 divided by 31, it's gonna give you this. So you just stop. Okay? That's the way you do it, so that you don't keep, excuse me, so you don't keep on trying 31, 37. Okay, so the next one is 54321. Okay, this is not an even number, but you add all these, 3 will go 3. Okay, so we do 54321 divided by 3, and it gives us 18107. 18107. 18107. 1 plus 8. We keep trying 3 again. 1 plus 8, 9. 9 plus 1, 10. 10 plus 7, 17. No. 3 is out. 5, no. 5 is out. 5 will not work. 7. 7. If we remove 7, 7 times 2. 40. At least we have done this, so what we could do is, let's go ahead to save time. Let's go ahead now. At least you have the idea of what I'm talking about, so we can save time in this video. Let's go ahead and find the square root of 18107. And that gives us 134. 18107. That gives us approximately 134.56. Okay, so let's just keep trying, up to that. 18107 divided by 7. Okay, that will not work. 18107. At least you know the idea. Okay, 18107 divided by 11. That wouldn't work. 18107 divided by 13. Didn't work. Decimal. 18107 divided by 17. Didn't work. 18107 divided by 19 is 953. So 19 worked. 19 worked. Let's see this. 18107. 19 worked. 181. Like I said, if it will work, it has to be a number that is less than 134. So 18107. Get out the last digit. 7 times 2 is 14. So add 18107. 18107 plus 14. That gives us what? 7 plus 4 is 11. 21. So that gives us 18121. You keep doing it. 18121. So we have 18121. Get 1 out times 2 is 2. Then you do 181. Oh, don't mind me. When you remove 7, you add the 14 to 1810. So 7 times 2 is 14. Then do 1810 plus 14. That gives you 0 plus 4 is 4. 1 plus 1 is 2. 1824. 1824. Okay? Then you come with 1824. With 1824, get the last digit. 4 times 2 is 8. Add it to 182. So 182 plus 8 is 2 plus 8 is 10. 190. 190. 19 can divide 190. 19 times 10 is 190. So 19 does that. Okay? So we're going to put 19 here. Okay? Then you now do, when you divide 18107 divided by 19 is 953. 953. So the remaining is 953. 953. Then you now check. 2 is out. Okay. You now don't waste time. All those numbers before 19 will not work with this. So don't waste your time on that. After 19 is 31. Sorry. After 19 is 23. 23. So do 953 divided by 23. It didn't work. 23 didn't work. Do square root of 953. Do square root of 953. That gives us 30. So let's keep doing this up to 30. Okay? So we just did 23. After 23 is 29. So do 953. Yeah, square root of 953 is 30 point something, okay? So just keep doing it up to 30. Not 30, but 30 point something. So now, do 953 divided by 29. It didn't work. Don't waste your time. Stop. So this is 953. Okay? So this is 3 times 19 times 953. Yeah. And we will still check our work. We'll still check our work, okay? So that's fine. So you now see that the GCD of 1, 2, 3, 4, 5 and 5, 4, 3, 2, 1 will be 3 exponent. This is 3 raised to power 1, 3 raised to power 1, 5 exponent 1, 8 to 3 exponent 1, exponent 1, exponent 1. Now, before we continue, let us make sure all the prime numbers appear on both of them. So here we will put times 19 exponent 0, and this is times 953 exponent 0. And this will be times 5 exponent 0 times 823 exponent 0. So the GCD will be 3 exponent minimum of 1 and 1 times 5 exponent minimum of 1 and 0 times 823 exponent minimum of 1 and 0 times 19 exponent minimum of 0 and 1 times 953 exponent minimum of 0 and 1. Okay? So this gives us 3 exponent minimum of 1 and 1. Of course, 1 is equal to 1, but you just bring out 1. Okay? 3 raised to power 1 times 5 exponent 0, minimum of 1 and 0 is 0, times 823 exponent 0 times 19 exponent 0 times 953 exponent 0. So this gives us now 3 times 1 times 1 times 1 times 1, and the answer is 3. Okay? The answer is 3. The LCM of 1, 2, 3, 4, 5, 5, 4, 3, 2, 1 will give us 3 exponent maximum of 1 and 1 times 5 exponent maximum of 1 and 0 times 823 exponent maximum of 1 and 0 times 19 exponent maximum of 1 and 0 times 953 exponent maximum of 1 and 0. So this gives us 3 raised to power 1. 3 exponent 1. I mean maximum of 1 and 1 has 1 is equal to 1. But you bring out 1. 3 exponent 1 times 5 exponent 1 times 823 exponent 1 times 19 exponent 1 times 953 exponent 1. And that gives us what? 15 times 823 times 19 times 953. So 3 times 5 is 15 times 823 times 19 times 953. And that gives us 2, 2, 3, 5, 3, 0, 9, 1, 5. Okay. Can we check our work? Can we kind of check to see whether we are right? Left hand side, right hand side. So left hand side would be 3 times 2, 2, 3, 5, 3, 0, 9, 1, 5. Right hand side will be 1, 2, 3, 4, 5 times 5, 4, 3, 2, 1. Right? So this times 3. So this gives us 6, 7, 0, 5, 9, 2, 7, 4, 5. And then 1, 2, 3, 4. 1, 2, 3, 4, 5 times 5, 4, 3, 2, 1. Gives us 6, 7, 0, 5, 9, 2, 7, 4, 5. Thank God it worked out. You can also put this in here. You can also put it in this calculator and check. You know, it should give you the same answer. All right. Let's do question 5. We still have some questions to do before we call it a night. before we go into the norm. Question 5. Cinco. So 5 do GCD of 1,000 and then 5040. Okay, so we have 1,002 because this is even number. Now 2 into 1,000 is 500, so 2 can still divide 500. Okay, so 2 can still divide 500 times 2 again. 2 into 500 is 250. 2 can still divide 250 times 2 again. So 2 into 250 is 125. So this is 2 cubed, folks. This is 2 cubed times, because we're not going to write 2 times 2 times 2, no. We write it this exponent. So 1,000 divided by 8 is 125, okay? Then the next one, 3 will not go, 5. 5 cubed. 5 times 5, 25 times 5 is 125. Then 5040, 2 can go. 5040 divided by 2 is 2520. So 2 can go again, divided by 2. That is 1260. So 2 squared. 2 can go again, or 2 cubed. Divided by 2 is 630. Okay? That's 8. Then 630 divided by 2 is 315. So 2 raised to power 4. 2 exponent 4. 16. Okay? 5040 divided. You always want to make sure you check it also. Okay? We now have 315. 3 plus 1, because 315. Then the next one you try 3. 3 plus 1 is 4. You want to start from the smallest, folks. You're going to start from the smallest. 3 plus 1 is 4. 4 plus 5 is 9. So 3 can go. 3. Okay? 315 divided by 3 is 105. 105. 1 plus 0 is 1. 1 plus 5 is 6. So 3 can go again. Okay? 3 times 3. So 105 divided by 3 is 35. And then 35 is 5 times 7. So this is 3 squared. 3 times 3. We put 3 squared times 5 times 7. Okay? Check it out. 16 times 9 times 35. Okay? Now, we now make sure everything is on both of them. So this is times 3 exponent 0 times 7 exponent 0. And this is 5 exponent 1, and this is 7 exponent 1. Okay? 2, 3, 5, 7. Now GCD of 1,000 and then 5040 is 2 exponent minimum of 3 and 4 times 5 exponent minimum of 3 and 1 times 3 exponent minimum of 0 and 2. Okay, times 7 exponent minimum of 0 and 1. Okay, so this will give us what? 2, minimum of 3 and 4 is 3. 2 cubed times 5, minimum of 3 and 1 is 1. Times 3, minimum of 0 and 2 is 0. Times 7, minimum of 0 and 1 is 0. So this will give us what? 8 times 5 times 1 times 1. And that is 40. So the GCD is 40. Okay? Now the LCM of 1000 and then 5040 will give us two maximum of 3 and 4, 2 exponent maximum of 3 and 4 times 5 exponent maximum of 3 and 1 times 3 exponent maximum of 0 and 2 times 7 exponent maximum of 0 and 1. So that gives us what? 2 exponent 4 times 5 exponent 3 times 3 exponent 2 times 7 raised to power 1 times 7 exponent 1. So that gives us 16. 2 exponent 4 is 16 times 125 times 9 times 7. And that is 16 times 125 times 63. 126,000. Okay, 126,000. Let's check it real fast. 40 times 126,000 is 504,000. Okay, that's 5,040,000. 5,040,000. Then you do, of course, 1,000 times this is still 1,000 times 5,040 is 5,040,000. So it worked. Okay? Alright, next one is question 6. Question 6. 6 is a says, right? Says. EC. 6 is EC. 6. So find the GCD and LCM of 9888 and 6060. 9888 and 6060. So 9888 will give us what? Two of course can go. So let's kind of get this real fast. 9888 divided by 2 is 4944. Divided by 2 again, 2427. Okay, divided by 2 again, 1236. Okay. Okay, divided by 2 again, 618. Okay, divided by 2 again, 309. So how many 2's now? I don't have a bigger screen to know how many. Okay, I have this 9888 divided by 2, 124944 divided by 2, 2 2's, 2472 divided by 2, 3 2's divided by 2, 4 2's divided by 2, 5 2's. 2 raised to the power 5. Okay? 9888 divided by 32. Okay? 2 raised to the power 5 times 309. 309, 3 can go. 3 can go. So 309 divided by 3 is 103. Okay? Times 103. Because 5 cannot divide 103, 7 cannot. Okay? Yeah. 11 cannot either. 13 cannot. Yeah, if we do 103, square root of 103, square root of 103. If we don't want to do that, that's fine. It's 10, so it's going to be less than 10. So we even stop at 7. Okay? So this is 8 for 9888. Then 60, 60, we know that 2 can go. So 60, 60 divided by 2, 30, 30, 1, 2, divided by 2. 15, 15. So 2 exponent 4, 2 exponent 2, okay? And 15, 15, okay? Jeremiah 15, 15. Oh God, remember me. Jeremiah 15, 15. Remember me, oh God. Okay, 3 can go, okay? 505, okay? Times 3. And then 5 can go, 101. 5 and then 101. Because 101, nobody, no, it's 101 is a prime number. Okay? So, this is the prime factors. You now do here times 5 exponent 0. This is exponent 1, exponent 1, exponent 1, exponent 1, exponent 1. And then times 101 exponent 0. And this here would be 2, 3, 5. This would be times 103 exponent 0. So our GCD of 9888 60 60 would be 2 exponent minimum of 5 and 2 times 3 exponent minimum of 1 and 1 times 103 exponent minimum of 1 and 0 times 5 exponent minimum of 0 and 1, okay, times 101 exponent minimum of 0 and 1. Alright, folks? Okay? Times 103 exponent minimum 1 and 0, 5 exponent minimum 0, 1, 101 exponent minimum 0, 1. Okay, so this will give us 2 exponent 2 times 3 exponent 1. Okay? Times 103 exponent 0 times 5 exponent 0 times 101 exponent 0. So this gives us 4 times 3. Okay, 4 times 3 times 1 times 1 times 1. And that gives us 12. 12 is the GCD. Alright? And then the LCM of 9888 and 6060 is 2 exponent maximum of 5 and 2 times 3 exponent maximum of 1 and 1 times 103 exponent maximum of 1 and 0 times 5 exponent maximum of 0 and 1 times 101 exponent maximum of 0 and 1. Okay, and that gives us what? 2 exponent 5 times 3 exponent 1 times 103 exponent 1. Excuse me. Times 5 exponent 1 times 101 exponent 1. And that gives us what? That gives us 32 times 3 times 103 times 5 times 101. Okay? And this is a 96. 32 times 3 is 96 times 103 times 5 times 101. And that is 499 3440. Okay? So 4993440, let's check this. LCM times GCD. 4993440 times 12 is 599,21280. And then let's do 9888 times 6060. 599,21280. Okay? Now we have 789. We have 3 more, and then we can call it a night. Okay, question 7. Question 7. These are the questions. Most of these questions we also did it using Euclidean algorithm. So, question 7. Now, question 7. Question 7 is a question that somebody asked me in the comments. Somebody asked me in the comments. Question 7. You are looking at GCD of, and yes, the person asked me of GCD, but we are going to do both GCD and LCM. GCD of 58595 and then 8526. So you can also do this with Euclidean algorithm. You can do it with Euclidean algorithm. You can do it with extended Euclidean algorithm. Now, what you don't want to do it with is the listing method. Remember, in the video on introduction to GCD, we talked about 3 methods. We talked about the listing method, the prime factorization method, which we are doing, and then the Euclidean algorithm method. Actually, it should be 4 methods. The 4th method is extended Euclidean algorithm, and we've done all the videos on those. So you don't want to use listing method to do this. No. That is suffering. You don't want to be suffering. No. So you can either use prime factorization method, which we are going to use now, or you can use the Euclidean algorithm method, or you can use the extended Euclidean algorithm method. And you can check your work with that on that website, the calculator on that website. So we try 58595. 2 this is not even number, so 2 is out. We try 3. 5 plus 8 is 13. Plus 5, 18. Plus 9, 27. Plus 5, 32. 32 is not a multiple of 3. 3 is out. 5 will work. 5. Right, 5. 58595 divided by 5. That is 11719. So we have 11719. 1 plus 1, 2 plus 7. Oh, yeah, 3 didn't work, so I won't waste time. 11719 divided by 7, because it's not going to be divided by 5, because it doesn't end in 0 or 5. So we now try 7. It's a decimal. So we try 11719 divided 11719 divided by 11. It's a decimal. 11719 divided by 13 is a decimal. Okay, so I'm gonna just do, we will do square root of 11719. So we know where we can stop. We don't square root of 11719. And that is 108. Hey, that's a lot. 108.25. Ah, that's a lot. Okay. So we did 13. No, with 11719 divided by 14, 15, 16, 17. Didn't work. 11719 divided by 14, 18, 19, 20, 21. Yeah. 20, 19. 19. No. 11719 divided by 23. No. 11719 divided by 29. No. 11719 divided by 31. No. 11719 divided by 32, 33, 34, 35, 36, 37. 37. No. 11719 divided by 38, 39, 40, 41. No. 11719 divided by 43. No. 11719 divided by 44, 45. I wonder which professor will ask this kind of question. Hey! Somebody asked me this question in the comments. Somebody asked me in comments. And imagine you're doing this to show your work and you're doing on time. Maybe you're timed. What professor will ask this? What professor will ask this question? Okay, 11719, 44, 45, 46. Maybe the professor wants to test your knowledge of prime numbers as well. Up to 108. Up to 108. Okay, 43, 44, 45, 46, 47 divided by 47. No. 11719 divided by 48, 49, 50, 51, 52, 53. 53. No. 11719 divided by 54, 55, 56, 57, 58, 59. 59. No. 11719 divided by 61. 61 is a prime number. Yeah. No. 11719 divided by 62, 63, 64, 65, 60, 67. 67. No. 11719 divided by 68, 69, 70, 71. 71. No. 11719. And you can use the table that's sieve of Eratosthenes. Okay, let me stop. You can use that table so you can check the prime numbers. You remove the composites and you now have only prime numbers remaining. 1171. Don't worry, I will go back when I do more topics. I will learn how to pronounce the name. Sieve of Eratosthenes or something. Okay. 11719 divided by 72, 73, 73. No? 11719 divided by 74, 75, 76, 77, 78, 79, 79. No? 11719 divided by 80, 81, 82, 83, 83. No? 11719 divided by 84, 89, 86, 87. So, some people think 87 is no. 3 can divide that. 87, 88, 89, 89. No, no. 11719 divided by 90, 91. Some people might think 91 is 91. No, 92, 90, 91, 92, 93, 94, 95, 96, 97. 97. No. 11719 divided by 98, 99, 100, 101. 101. Okay? No? 11719 divided by 102, 103. 103? No, no. 104, 105, 106, 107, 107. 11719 divided by 107. No. Okay. Again, we stop here. Again, there's no other, there is no other prime factor. Okay, we now do 8526. Okay, 2, because this is even number. So 8526 divided by 2 is 4263. 4263. 3 can go. 3 can go. 4 plus 2 is 6 plus 6, 12 plus 3, 15. Divided by 3 is 1421. So this is times 3 times 1421. 7 can go. Or let's still do 3. 1 plus 4, 5 plus 2, 7 plus 1, 8. So 3 is out. 5 will not work. 7 can go. Okay, divided by 7. 203 times 203, that times 7. Then times 203. 203 is a prime number. Right? 203 is a prime number. Is that right? Yeah, 203 is a prime number. Yeah, it's a prime number. You guys know what I tested right now, right? 203 divided by 11, 203 divided by 13. Okay, now, this is what we have here, and we see that it's nothing that, you can have this is 1, 1, 1, 1, 1, 1. This is times 2 exponent 0, times 3 exponent 0, times 7 exponent 0, times 203 exponent 0. This is times 5 exponent 0, okay, times 11719 exponent 0. I mean, if you want to, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If you want to show all your work, that's fine, but there is nothing in common. So GCD, there is nothing in common at all. 58595, 8526 is 1. Because this will be 5 exponent 0. Look at what it will be. This will be 5 exponent 0, because the minimum of 1 and 0 is 0. Times 11719 exponent 0 times 2 exponent 0 times 3 exponent 0 times 7 exponent 0 times 203 exponent 0. And this is just 1. The GCD is 1. It's 1. There is nothing in common. Only 1 is the common factor there, and also the greatest common factor, greatest common divisor. Okay, now the LCM of this 58595, 8526. There is no common factor at all. So the LCM, remember, 1 times the LCM will still give you this times this. Okay, so if you want to do it 5 exponent 1 times this exponent 1 times, if you want to do it that way, that's fine. But otherwise, like, this is what I'm saying. If you want to do 5 exponent 1 times 11719 exponent 1 times 2 exponent 1 times 3 exponent 1 times 7 exponent 1 times 203 exponent 1, you can do it. But I'm not going to do, if I don't see any common factor, I'm just going to do this, okay? I'm just going to do 58595 times 8526. That is what I will just do, because there's no common factor. And remember, the GCD times the LCM gives you the product of the two numbers. GCD is 1. So that automatically means that the LCM will just be the product of those two numbers, And if you do that, 58595 times 8526, it gives you 499,580,970. Okay, that's that for question 7. Two more questions. The next one is question 8. 7 is siete. 6 is 6, right? 7 is siete. 8, Osho. Isato. Osho. 8. Question 8. GCD of 216,729. Okay? So here we have 216. 216 is 6 cube. 216 is 6 cube. 6 cube. So that is 2 cube times 3 cube. Right? Yeah. 216 is 6 cube. 6 cube. And that is 2 times 3 all cube. Which is because you want it in prime factors. So this is 2 cube times 3 cube. Right away. 8 times 27. 8 times 27. 8 times 7, 56, 65. 8 times 2, 16 plus 5, 21. Yeah. 2 cube times 3 cube. Yes. 729 is 81 times 9. 9 times 9. 81 times 9. 729. So 9 cube. 9 cube is 3 times 3. Because remember, you can do this. You can do this by exponent. So you can do it this way. You can do it like this: 3 cube times 3 cube, which will give you 3 plus 3. Exponent. Remember, laws of exponents. And that is 3 raised to power 6. Or you can just do it 3 cube all cube. Sorry, 3 squared. 3 squared because this is 9 cube. Or you can say 9 cube is 3 squared all cube. If you're doing this here, the same base. So you add the exponent. This is another law of exponent. 9 is 3 squared all cube. When you have 2 exponents, an inside exponent and an outside exponent, in this case you don't add, you multiply. So 2 times 3, and that is 3 raised to power 6. Okay, so now we have this times, okay, this is 2, 3, this is 3 raised to power 6 times 2 raised to power 0. Okay, times 2 exponent 0. So which is 1. So the GCD of 216,729 is, this is what we are looking at first, folks. This is what we need. We are looking at this, the prime factors. So this is 2 exponent minimum of 3 and 0 times 3 exponent minimum of 3 and 6. Okay? Right? Now let's make sure we check this. This is 6 times 27, 216. 3 exponent 6 is 729. Okay? Now, we now say that this is 2 exponent 0, because minimum of 3 and 0 is 0, right? Times 3 exponent, minimum of 3 and 6 is 3. So this is 1 times 27, and that is 27. 27 is the GCD. Okay? Then the LCM of 216 and 729 would be 2 maximum of 3 and 0 times 3 exponent maximum of 3 and 6. And that will give us 2 exponent 3, maximum of 3 and 0 is 3. times 3 exponent 6. Maximum of 3 and 6 is 6. So this is 8 times 729. Okay? 8 times 729. 5832. 5832. Okay, and that is it. So 5832, we can check this. 5832 times 27 is 157464. And then 216 times 729 is 157464. Alright, thank God for that. Now, last but not the least, nueve, right? Nueve, 9. Iteghete, itoolu, iteghete, question 9. Iteghete. Question 9. Okay. So, like we said in part 1, because the last question 9, has 3 numbers. Okay. It says a GCD of 216729 and 7962. 7962. So one of the nice benefits of using the prime factorization method is that you can find the GCD and the LCM of more than 2 numbers. If you have an array of numbers, okay, more than 2 numbers, you can find the GCD and the LCM with this easily. That's the nice thing with this method. So in this particular website also has the calculator for finding. I called it an array because I took it that it's more than 2 numbers, but you can still use it for 2 numbers. An array, if you have 2 numbers, it's still an array. But assuming you had more than 2 numbers, then you have to use the calculator that I called array to do it. Okay, so we have the first one here. 216 is 2 cubed times 3 cubed. 729 is 3 raised to power 6 times 2 exponent 0. Now 7962. 2 can go here. Let's get 7962 divided by 2. 3981. So 3981. 3 can go. So divided by 3 is 1327. So times 3. This is times 1327. 1 plus 3, 4, plus 2, 6. 6 plus 7, 13. No. So 3 cannot go anymore. 5 cannot go. Let's try 7. 7 cannot. 1327 divided by, after 7 is 11. No. So 1327 divided by, after 11, 13. No. So let's take the square root of 1327. Square root of 1327 is 36 points. Okay, so let's try till 36. So 1327 divided by, after 13 is 17. No. 1327 divided by 19. No. 1327 divided by 23. 19. 23. No. 1327 divided by 29. No. 1327 divided by 31. No. 1327 divided by 30. Yeah, that is it. That is it. So 1327 1327 will not have is prime. 1327 will give you prime. Okay, because we've tried all this and it didn't work. Okay, so it's gonna give us prime. So this is 2 raised to the power 1, 3 raised to exponent 1, and 1327 exponent 1. Alright. Right? We hope we tried all of them. 31, 37. Yeah. 1327 divided by 10. We did that. Okay. Alright. So we now have that the GCD of 216,729,7962 will give us 2 exponent minimum of what? 301. Do you see what I'm doing now? Minimum of 3, 0, and 1. See that? Times 3. Now let's put this times 1327 exponent 0 times 1327 exponent 0. So this is times 3 exponent minimum of 3, 6, 1. 3, 6, and 1 times 1327 exponent minimum of 0, 0, and 1. Do you see what I'm doing? Okay. So this will give us now 2, minimum of this is 2 exponent 0 times 3, minimum of this is 3 exponent 1. 3 exponent 1. Minimum of 3, 6, and 1 is 9. Then times 1327 exponent 0. The minimum of 0, 0, and 1 is 0. So this will give us 1 times 3 times 1, and that is 3. Our GCD is 3. Okay? And we can find our LCM. Our LCM of 216,729,7962 would be 2 exponent maximum of 301, 30, and 1 times 3 exponent maximum of 30 and 1 times 1327 exponent maximum, 3, 6, and 1 for 3, 6, and 1 times 1327 exponent maximum of 0, 0, and 1. And that will give us 2 exponent 3 times 3 exponent 6, 3 exponent 6, are you guys with me? Times 1327 exponent 1. Okay? Right? So what's that gonna give us now? So that will give us now 2 exponent 3 is 8 times 3 exponent 6 is 729 times 1327. So our answer will now be 8 times 729 times 1327. And that is 7739064. So I put this question on purpose. This is the way we found the GCD, and this is the way we found the LCM. But in the check, when you multiply this, if you do 7739064 times 3, it will not give you the same thing as 216 times 729 times 7962. It's not going to give you the same thing. So my assignment to you is this. Find a way to check this. Okay, find a way to check it. We've been checking the one whereby it's 2 numbers. You can still verify this in this calculator on the website. But I want you to find a way to, find any theorem is your assignment now. Okay? Alright. We're going to stop here for tonight. If you have any questions, please feel free to ask me. Thank you so much for listening, and you have a good night.